Hello everyone, this is Raghavi, Assistant Professor from Department of Computer Science. Today we are going to see about the example program for image restoration in MATLAB. Here first I have read the image using the imread function and displaying the image using subplot. Next, converting the image into a grayscale using the function RGB to gray. Since we have to apply a motion blur and the noise to the image, we have to convert the image original class into double. For that I am performing into double for converting a class of the original image into double so that it can accept the floating point values. Next, motion blur is applied to the input image using the function f special of have to specify the filter name, that is motion, and the parameters such as length and the theta value. After creating a f special function, this is passed as an input to the infilter function. The infilter function is applied to the image, that is the converted double image, and then a special function is applied. Then we need to specify the convolution or a correlation. Then the boundary options as a circular. Then I am displaying it using subplot. Next, Gaussian noise is applied to this blurred image with the mean value as 0, the variance value is 0.01, and displaying it using subplot. Next, in order to restore the image which contains a noise and the motion blur, we have to remove it using a filter, that is the restoration process. For that we use the function deconvolution Weiner. Of that we have to pass the blurred and the noisy image as an input, and I am displaying it using a subplot. Let us run the program to see the output. This is the output which we get after executing the program. This is the original image. After applying the motion blur, we get the resultant image as the second image. After adding a Gaussian noise, we get the resultant image as this. Next, without specifying the variance and the mean value, it takes the noise to signal ratio value as 0 so that nothing can be viewed in the image. By specifying a noise to signal ratio value, we can eliminate some noise, and finally we obtain a original image. Next, let us say a example program for a edge detection in image segmentation. For performing edge detection, I am reading an input image using the imread function rgb.png image. Since it is a color image, I am converting it into a grayscale. For that I am using a function RGB to gray of input image. Next, we have to apply different edge detection operators to this converted grayscale image. We have to use the function edge for applying edge detection operators of this converted input image, we have to specify the operator such as private. First, let us apply a private operator. Now I display the original image, that is a converted grayscale image. is the image which is converted into grayscale. Next, let me display the image to which the pivot edge detection operator is applied. This is the result which we get after applying a pivot edge detector. Next, we can apply log edge detection operator and we display using log edge detection operator. We get the output as shown in the figure. Next, by applying a sobel, we get the resultant as this, and finally when applying canny edge detector, we can see that when applying pivot, log, sobel and canny edge detector gives the better quality of a image and the edges are detected to the maximum. Thank you for watching.